Now, the parametric equation of a curve gives the path traced out by a particle against time t. Right, so RT equals t comma 2 sine t 2 cos t. Find RT at the following times, right? So R of t when t equals 0, that's going to be given by t 2 sine t and 2 cos t. Right, so t is going to be equal to 0, so we have 0 there, 2 sine 0 there, and 2 cos 0 there. Now, what's sine of 0? Sine of 0, according to my calculator, is 0, so we get 0, 2 times 0 is 0, and cosine of 0 is going to be 1, so we get 1. So this here is the point. This is where the particle is when the time is 0. Now, where's the particle going to be when t equals pi over 2? So t equals pi over 2. So where's the particle going to be when t equals pi over 2? That's going to be pi over 2, 2 sine pi over 2, comma 2 cos pi over 2. So pi over 2, sine pi over 2, we need a calculator in rads, so let me change this thing to rads. Shift and mode for this one, 4, right, so 2 times, well, just get sine pi over 2, that's 90 degrees, sine of pi over 2 is 1, so 2 times 1 is going to be 2, and then we cos pi over 2, I'm thinking that's going to be 0, so cos pi over 2, close the bracket, calculator is in rads mode, and we get 0. 2 times 0 is 0. So when the time has gone as far as pi over 2, this is at t equals pi over 2. These three numbers describe the location of the particle. Now we're going to get the position of the particle when t equals pi. So remember we had this was the way the thing was, 2 cos t, right? So the position is going to be, the x coordinate is going to be pi, and we have 2 sine pi and 2 cos pi. So sine of pi is 0, so we're going to have x, and our y coordinate there is going to be 2 times 0 is 0. The cos of pi, I'm guessing, is going to be 1. Just confirm it there. It was minus 1. So 2 times minus 1 gives us minus 2 on our xyz, right? So this is t time equals pi. Next up then we have t when t equals 3 pi over 2. Where's our particle going to be? It's going to be 3 pi over 2 on the x axis, 2 times sine 3 pi over 2 on the y axis, and 2 times cos 3 pi over 2 on the z axis. This comes out as 3 pi over 2, comma, 2 multiplied by sine 3 pi over 2 comes out to be minus 2, and then we have 2, I'll change my sign on my calculator, oh, it won't let me, 2 multiplied by cos 3 pi over 2 rads, and I get 0. So this is where the particle is when the time is 3 pi over 2. And finally, we have time equals 2 pi. Just going to be the same technique again. So when t equals 2 pi, the position of the particle is going to be 2 pi on the x-axis, 2 sine 2 pi on the y-axis, and 2 cos 2 pi on the z-axis. So that gives us 2 pi, 2 multiplied by sine 2 pi equals 0, and then we have 2 multiplied by cos 2 pi gives us 2. Now I'm looking at part 1 there again, hence describing more as the path that the particle traces out. You see, I've summarized the values we got there, 0, 0 and 1. So we can graph it on this here. This is our x-axis, y-axis and z-axis. And I've scaled this guy with our rads and the other end with 1 and 2, like that. So to scale the first point at time 0, we're going to be 0 on the x-axis. So we'll start at origin, 0 movement here, 0 movement here, and 1 step up, and that's where we are when time equals 0. The particle is. With time equals pi over 2, we're pi over 2 out on the x-axis. Then we're 2 on the y-axis, so we're going out as far as here on the y-axis, out to there, and we're 0 on the z-axis, so we're not going up or down, so our point is out here. You can imagine we're traveling along this x-axis in time. Point number 3, we're pi units out on the x-axis, so we're out to here, and we're 0 shift left and right on the y, and we're gone to a depth of 2 on the z-axis from this point straight down, so you can imagine we're down here somewhere, right? That's point number 3. Then we have 3 pi over 2, we start out here on the x-axis, and on the y-axis we're minus 2, so we're heading this direction here 2 units, somewhere out here. So you have to use your imagination now. And then finally we have 2 pi out on the x-axis, 0 left or right on the y, and we're climbing to a height of 2 above this imaginary point in space, 2 pi here. We're climbing to a point of 2 units up. So somewhere here. So then what is this? What is the particle tracing out? It's like a spring that's coming out. It was hard to do this justice. So that was 1. That's point number 1. That's point number 2. 3. Which one was this now? Pi. Yeah, minus 2. That's point number 3. This is point number 4, is it? 3 pi over 2. Minus 2 and 0 height, yeah. So that's point number 4. And then we have 2 pi, 0 on the y, and the height of 2, that's point number 5. So it's going to go like, you know, like a spring coming out. 2, 3, 4, and 5. Now, don't worry about the drawing anyway. We're not asked to do a drawing, but it's like a spring that's rotating around the x-axis and is coming out towards us. So the fancy word for that, describing more as the path the particle traces out. The particle traces out a helix along the x-axis. So that's it for part 2.